My name is Nir Dvir. I'm working for Massivit 3D. We are located just a few minutes away from Tel Aviv. We are now at our headquarters. I heard a lot of time that everything that can be composite material will be composite material, and Massivit 10,000, the system that we're going to talk about here, should help in solving this issue, enable more composite material by digitizing tooling for composite material. Yeah, I'm fighting with the system. So Massivit 3D transforming manufacturing of large part. For those of you that doesn't know Massivit 3D, one slide, just very short. First of all, we are talking about disruptive 3D printing technology that prints 30 times faster than other technologies in the market. We founded in 2013. We have more than 50 live patents, and we went public just now in February 2021 in Tel Aviv Stock Exchange. More than 140 units are installed in 40 countries around the world, and the people behind the success of Massivit 3D are pioneer founders in the 3D market, but also in the 2D arena. You most probably can recognize at least 50% of the brands here, and those are brands that are leveraging, as of today, Massivit 3D technology. The markets that Massivit 3D exist as of today are very diverse, and I want to show you a few examples. For example, end parts for yachts. End parts for yachts. Functional parts for trains. Thermoforming molds for aerospace, as well as big full-scale prototypes. Those are the areas that we exist today with our units around the world. If we want to talk about, I just lost my, someone is, oh, you don't see my presentation? Just a second, I want to make sure that I'm sharing the right presentation for you. Okay. Yes, just a second, I need to be able to. Yeah, so you can see in the small pictures our GDP technology, gel dispensing printing technology, actually a tip that is pouring a lot of gel at once, which is cured by UV light. By that, we print extra fast, extra large scale, and decrease cost. Massivit has a portfolio of products, starting from Massivit 1800 Pro, continuing by the machine in the middle, which is the Massivit 5000 that we just launched to the market, and the Massivit 10,000, again, jumping, and the Massivit 10,000 that is will be go to beta by the end of the year. Just to give you an idea where we are here and where we're heading to, additive manufacturing is divided into three parts: rapid prototyping, tooling, and manufacturing. Today we are more in the rapid prototyping, a little bit of tooling, and the Massivit 10,000 is fully dedicated for tooling and as well of manufacturing in the future. Just a second. I'm sorry about the technical. Screen sharing. אני לא מצליח. Okay, if we go deeper into the Massivit 10,000, we recognize a bottleneck. The bottleneck is the mold production. If you're coming from the mold production, you can surely recognize the space that you need, the hard work, the time, and the storage. In order to create a mold, you need up to 19 steps, if not more, in order to create from your CAD design a masterpiece, from this master to create the mold, and out of this mold to create the part. We at Massivit 3D managed to shorten those steps from 19 to only 4 steps. What we are going to do, or what we are doing today, we are printing the mold directly. We print the mold with our cast-in motion technology that we are going to see. We are removing the pattern, we cure it at the oven and sand and polish it. And by that, we cut a lot of time and, of course, enables molds to generate molds within days and not in weeks. So how does it work? Let me try and show you a video that is presenting Massivit 10,000 technology. Till I managed to do that, you can see on the left side of the picture, on the left side, you can see a sandwich construction, actually 2 walls, and those 2 walls are printed by Massivit, and into those 2 walls we are casting a material. Okay. No, I need to stop sharing and then share the video. Okay. That's screen sharing.
The composites industry's solution for mold making of an item, such as this sports car seat backing, is based on legacy technology. This usually means using wood or plastic foam core milled by CNC and followed by manual hand layup of multiple fiber reinforced layers. Naturally, this procedure is slow and expensive. This legacy approach also significantly limits shape and size options and is unfriendly to the environment. The people behind the Massivit large format 3D printing innovation are about to introduce the next generation alternative.
Our uniquely rapid additive manufacturing technology, integrated with proprietary printing materials, powers the industrial-grade Massivit 10,000.
Using 1 print head and 1 dispensing head, the forming pattern is being 3D printed, while the dispensing head simultaneously pours a highly durable and robust resin. The result achieved in unparalleled record time is a temporary double-layer shell with a resin cast in between. Now all that remains to be done is the swift removal of the two external pattern layers. By dipping the printed piece in plain water, both external layers fall off in small pieces, leaving the desired product ready for use. Cutting costs and boosting productivity
with the Massivit 10,000.
Okay. I think I need to reshare. Okay, Massivit 10,000, as you saw, is using two core technologies. The first core technology is gel dispensing printing, where we are printing water breakable walls, actually hollow models. And the second is the cast in motion, where we are casting material between those two water breakable walls. In this case, we talk about epoxy material that we cast. We took the decision to start with epoxy as we are targeting the composite material and we want epoxy to touch epoxy. So again, the key benefits, we talk about high-speed printing, big bed of 1.2 by 1.5 meter, and with a height of 1.5 meter, and the casting material between the two walls. More specifically, we are using two printing heads. The first head is using the GDP technology, which allow the printing of the sacrificial pattern, creating complex shapes, of course, in rapid speed. We are using no support, and with it also no waste, controlling different resolution and reaching the accuracy that the market needs. On the other side, we have our casting head, which enable us together with the GDP to create the cast in motion technology. And here we are casting between the walls the material that we want to cast in order to get to the mechanical strengths as well as to the material resistance in terms of thermal and chemical that we want to achieve. By using the cast in motion technology, we create efficient digital tooling. We took a video out of our prototype a day ago, and I want to start to try and so we talk about the reduction in terms of time, labor cost, which end up by reduction of the cost of creating mold. Cannot transfer the. Cannot move the slides. Sorry about this. I'm really. No. Okay. Okay. In terms of application, maybe I can very quickly show an example that we worked on. And this is probably the first digitally printed race car seat mold, which is about 1 meter. You can see that it is already connected to the tooling, and by creating the mold, I can already take the decision how do I build, what is the wall thickness, the tools that I'm building, actually saving also a lot of time, not only by preparing the mold, but also the tools for the mold. you can see the 3D printed shell and the mold after we dip it into water. And at the end of the day, a carbon seat that was done by one of our customers, as we are not manufacturing carbon parts, only the molds for the carbon parts. Just to be more specific, we talk about, in this case, about a mold which is about 50 kilograms at this stage of development, and was printed within 24 hours, or if we want to be more specific, ready for use within maximum 2 days. Some more application that are coming from our market, from our customers. We talk about catamaran hydrofoil skin that can print it within hours, or radom for drone, which we already printed here. But those are only examples, and the market of a composite material is huge. We see the coming markets coming from automotive, marine and rail, but also from defense, aerospace, construction, and renewable energy, of course. It is a huge market for us, and by solving this bottleneck of mold manufacturing, we believe to be able to enable much more business for the composite material world. Thank you, and I'm truly sorry about the controlling the platform, not in a professional way.
Isn't a question, when will this technology be launched?
It's a good question. When will this technology will be launched? We are planning to have our first beta by Q4 2021, and the year after we will start with actively selling the product to the market. But if you don't have the patient to wait till it's in the market, please give us a call, and we will be more than happy to assist you. We are looking for more partners.
What is the surface quality of the tool? Class surface.
What is the surface quality of the tool? When you read, can they hear us? Okay, so what is the surface quality of the tool? This is a good question. The surface of quality of the tool is actually what we choose, and we can choose between a very high resolution and something that is slower in terms of printing, or a rough resolution, and then use a milling system. In any case, there is a milling or a polish process that has to be done. We are truly sorry about it, but we are not cutting it out. Still, there is work to do in order to get to the needed surface quality.
How often can the tool be used?
How often can the tool be used? I think this is an excellent question, and I think that it's this number has to do with the quality of the tool. We designed the tools to withstand 250 parts. Also, we haven't tested it yet. Okay, we haven't come to this number of 250 parts in terms of a priority of testing, but it is designed for. We believe that by the time that you would get your mold in a conventional way, we will be able to produce 4 molds, if not more, and you will be able to start your production immediately. And so we are also not targeting thousands of parts to be done out of our molds, but hundreds. and for that we would like to remain under the numbers of 250 and even lower. We don't have a request for higher for that at the moment.
What type of materials or fillers can be poured inside the double-walled pad?
This is a good question. At the moment, we cast epoxy material. We casted our first epoxy material. Now we are in a development stage for the beta test of a new epoxy material. But you're right. The technology will allow us to cast diverse materials. Okay, we already managed to cast some wood, and I hope that in the future we will be able also to cast other materials. I saw already a small piece of aluminum, but I haven't seen it casting, so I cannot say. But you're right. The idea is really to use the technology and to develop it in the in the next years to cast new materials.
What is the highest temperature tooling material you can use in the machine currently?
Okay, the highest temperature that we can use today is 120 degrees Celsius, and our material that will go into beta testing will already fit to 150 degrees Celsius with a CTE that is lower than aluminum. If this is the question for the temperature, so we optimize the CTE also for the temperature. Where do you see all those questions? I don't see them. Okay, I will wrap up. I will share my screen. I'm not sharing my screen. Yeah, that's fine. The next one. Okay, so actually I want to wrap up, and I know that 20 minutes or 25 minutes are not enough in order to share much information. I urge you to write us or to write me, and I will be more than happy to discuss with you. Please visit us at the JEC booth, meet our people, or email us. Again, Massivit has more than 140 units around the world, generating a lot of already end parts to customers. But the Massivit 10,000 is entering into the new world of composite material by eliminating the bottleneck of mold manufacturing. We digitize the mold manufacturing process. Thank you very much.